Our focus today is on factoring quadratic expressions. So the first thing you want to do when you are factoring any quadratic expression is look for the greatest common factor. In our first example, we have a coefficient of 3, a coefficient of 9, and a 6. All three of those have a factor of 3. So the first thing we're going to do is factor out the 3. So 3 times x squared gives me x squared. 3 times 3x gives me 9x, and 3 times 2 gives me 6. So that's as far as we're going to go on this slide, is factoring this far. We'll talk about how to factor things with x squared in them in a few minutes. All right, on the second one, we have a 16, a 12, and a 4. All of these have a factor of 4, so we're going to factor out the 4. 4 times 4x squared gives me 16x squared. 4 times 3x gives me 12x. And 4 times negative 1 gives me the minus 4. On the next one, we have 7p squared plus 21. Both of those have a factor of 7, so we're going to pull out the 7. And we're left with p squared plus 3. In addition to factors that are numbers, we want to also look for common factors of x. In this case, both of the two portions have an x in them, so we can factor out one of those x's, and x times 5x gives me 5x squared, and x times 3 gives me the 3x. If I look at this next one, I have an x squared in this term and an x in that term. So I can factor out an x again, and I would be left with 10x minus 4. But this also does have a common factor of 2 in it, so I should also factor out that 2. So I'd have 2x times 5x minus 2. When we're factoring things that have an x squared in them, the first thing that we want to look at is the sign of our c. The things in the last place are going to have to multiply together to give us our c. So if I have a plus c there, that means that my two numbers have to multiply together to give me a positive. I can get that by either multiplying together two positive numbers or two negative numbers. So if that is positive, I need to have the same sign in both of my factors. And that sign is going to have to be the same as the first one, the sign of my b. So this positive sign here tells me that they're both going to be the same, and the blue part tells me that they're both going to be positive. If the blue part was a negative, then the red positive would tell me they're both the same, and it would be a negative in both of those. If the sign of c is negative, that tells me that I have to have opposites in my factors. So one of these would have to be a positive and one of them would have to be a negative. If I take a look at this, again, the first thing I'm going to do is look at the sign of my constant. That one is positive, which tells me I have to have the same sign in both of my factors. And this positive here tells me that they're both going to have to be pluses. Now I need things that multiply together to give me 7. Well, the only factors of 7 are 7 and 1, so this one's going to be pretty easy. And the front things have to multiply together to give me x squared, which again would have to be x and x. Once you're done factoring, always go through and double check that you got the right answer. This would give me x squared plus x plus 7x. X plus 7x gives me the 8x plus 7. The second one, I'm going to see that there's a plus sign here, which means I have to have the same sign in both of my factors. But on this one, the sign in front of the 17 is negative. So that tells me that both of these are going to have to be minuses. I've got an x squared here, which means I need an x and an x out front. Then I'm going to make a list of the factors of 72. I could do 72 and 1, or I could do 2 and 36, or 3 and 24, or 4 and 18, or 6 and 12, or 8 and 9. Now because these both have negative signs in them, my two numbers need to add up to be 17. The two factors that add to 17 would be 9 and 8, so it's going to be x minus 9 and x minus 8. Again, when you're done, just double check. X times x would be x squared, minus 8x minus 9x gives me minus 17x, and minus 9 times minus 8 gives me the plus 72. In this one, I have a minus 12, which tells me that one of these has to be positive and one of them has to be negative. The x squared, I've got to have x and x out front. And now I need factors of 12, which could be 1 and 12, or 2 and 6, or 3 and 4. Now since these have opposite signs, I need numbers that have a difference of the coefficient of this x, which would be a difference of 1. So that's going to be my 3 and 4, and the one that's the biggest has to go with the sign that is in front of my b. So in this case, my b is negative, so the bigger number, which would be 4, goes with the minus sign, and the smaller number is going to go with the positive sign. Again, double check when you're done just to make sure you didn't mess up. X times x is x squared, minus 4x plus 3x gives me the minus x, and 3 times negative 4 gives me the minus 12. Alright, here I have a plus 8, which tells me they're going to have the same sign, and this positive in front of the 6 tells me they're both going to be positive. It's just a 1x squared, so I need x and x. And now I need factors of 8 that add up to 6, which happens to be 4 and 2. Since it's plus in both of them, it doesn't matter which one goes first. Double check. X times x would be x squared, plus 2x plus 4x gives me the plus 6x, plus 8. This plus sign tells me that I need to have both the same signs inside my two factors, and this plus tells me that they're both going to be positive. So it's 1x squared, so I need x and x. Now I need factors of 32 that add up to 12. Let's start off by making a list of factors if you can't figure it out just off the top of your head. This one, it ends up being 8 times 4 is 32, and it adds up to 12. This plus sign tells me that I need to have both the same signs, and this minus tells me that they're both going to be negative. It's 1x squared, so x and x, and I need factors of 8 that add up to 6, which would be 2 and 4. Now give these two a try. They're both going to be positive for this one. X and x, factors of 40 that add up to 14 would be 4 and 10. For the second one, they're both going to be negative. X and x, factors of 12 that add up to 7 would be 3 and 4. These two are both going to be negative, x and x. Factors of 24 that add up to 11 would be 3 and 8. Since this is a minus sign, I know that I need one of these to be positive and one to be negative. So x and x, and this time I need factors of 32 that have a difference of 14. So 16 times 2 gives me 32, and those have a difference of 14. Now since this 14 is negative, I need the bigger number to go with the minus sign, so it's going to be x minus 16 and x plus 2. This minus sign tells me I need one positive and one negative, so x and x. I need factors of 10 that have a difference of 3, which would be 5 and 2. This is a plus 3x, which means I need the bigger one to go with the positive, so it'll be x plus 5 and x minus 2. Down here, again, I have a minus 5 as my constant, so I need one of these to be a positive, one to be a negative, and I need factors of 5 that have a difference of 4, which would be 5 and 1. This is a positive 4x, so the 5 has to go with the plus, and the 1 is going to go with the minus. The first thing you want to do with any quadratic expression is look for a greatest common factor. Now, if you've already pulled out all greatest common factors and the coefficient of a is not 1, things get a lot more complicated. Now, you know we need to break this up into 2 sets of parentheses. So you can just do a guess and check. In order to get 3x squared, I'm going to need a 3x and an x. This one would be relatively easy because the plus sign tells me they're both the same, so they would both have to be negative. And 5 only has factors of 5 and 1, so there's really only 2 things to try, but it can get a lot more complicated. So there is another method that will give you the right answer, which I'm going to go through now. If guess and check works for you, it's fine to do it that way. But if you're having difficulty with that, because there can be several different ways of getting an answer that way, this way will always work and get you to the correct answer. But again, you need to pull out greatest common factors first. In order to use this method, which is sometimes called the bottoms-up method, we're going to completely change the equation for a second. We're going to take the a and multiply it by the c. So we're going to leave the x squared as just x squared, getting rid of that 3, minus 16x, we leave that middle term the same, and now we add a times c, 3 times 5, which would be 15. Now we're going to factor this the same way we've been doing. We need an x and an x. This is a positive sign, so they're both the same. This is minus, so they're both going to be negative. And I need factors of 15 that add up to 16, which would be 15 and 1. Now this is the factored version of this equation, which is a different equation. So what we are going to need to do is end up bringing the bottoms up here. Now we started off by multiplying the 3 by the 5. So since we started off by multiplying by 3, we're now going to divide both of these by 3. Now 15 over 3 can simplify. So we have x minus 15 divided by 3 gives us 5. And 1 divided by 3 can't simplify, so we're going to take the bottom portion of this fraction and bring it up in front of the x. So 3x minus 1. Now, double check this and make sure that we do actually end up with the first equation that we started with, because this one especially, things can get complicated and you can end up making simple mistakes. So x times 3x gives me 3x squared, minus x minus 15x gives me the minus 16x, and negative 5 times negative 1 gives me plus 5. So my final factored form of the original expression is x minus 5 times 3x minus 1. So again, our first step for these questions is look for a greatest common factor. In this case, there is none, so we're going to take the 2 and multiply it by the 12. So we're going to have x squared plus 11x plus 2 times 12 is 24. Now we're going to factor this. So x and x, This plus tells me they need to both be the same. This plus tells me they're both going to be positive. And now I need factors of 24 that add up to 11. Alright, so that would be 3 and 8. And now for the bottoms up, I multiplied by 2, so I'm going to divide both of these by 2. 3 over 2 cannot simplify, so I'm going to bring the bottom up. So I'm going to have 2x plus 3. And 8 over 2 simplifies to 4x plus 4. Go ahead and give this one a try. If you like the guess and check way, that will work. If you like the way I just showed you, that'll be fine too. So your final answer should be x plus 1 times 4x minus 3. So we start off taking the 4 times the 3, so we have x squared plus 7x plus 12. So I need x plus for both of these. And I need factors of 12 that add up to 7. So that will be x plus 3 and x plus 4. Now I started off by multiplying by 4, so I'm going to take this and I'm going to divide by 4. 3 over 4 cannot reduce, so this 4 from the bottom is going to come up. So I'm going to have 4x plus 3, and 4 over 4 reduces to 1, so x plus 1. So again, start off, take the 2 and multiply it by the 6. So we have x squared minus 7x plus 12. So I need x minus and x minus, so I need factors of 12 that add up to 7, which would be 3 and 4. And now since I multiplied by 2, I'm going to divide both of these by 2. 3 over 2 cannot reduce, so I'm going to bring the bottom up, and I have 2x minus 3, and 4 over 2 reduces to 2, so x minus 2. Alright, so we start by multiplying the 4 times 15, so we have x squared minus 4x plus minus 60. So we're going to factor this. This minus tells me that one of these is going to be a minus, one's going to be a plus. So I need factors of 60 that have a difference of 4. And that would be 6 and 10. This is a minus 4, so the bigger number needs to go with the negative. So it's going to be x minus 10 and x plus 6. And since we multiplied by 4, we're going to need to divide by 4. So x minus 10 over 4 does reduce to 5 halves. And x plus 6 over 4 reduces to 3 halves. Now neither of these reduce completely, so we're going to take the bottom part from the fraction that's remaining and bring that up. So it's going to be 2x minus 5 times 2x plus 3. So start off taking the 2 times the 9, so we would have x squared plus 7x minus 18. So we will have x plus and x minus. So I need factors of 18 that have a difference of 7, which would be 9 and 2. This is plus 7x, so I need the 9 to be with the positive, the 2 to be with the negative, and I started off multiplying by 2, so I'm going to divide both sides by 2. 9 over 2 can't reduce, so the bottom comes up. 2x plus 9 times x minus 2 over 2 reduces to 1. We start off multiplying the 3 and the 12, so we have x squared minus 16x minus 36. So x plus and x minus. I need factors of 36 that have a difference of 16, which would be 18 and 2. This is minus 16, so I need the bigger number, the 18, to be with the negative, and the 2 to be with the positive. Now I started off by multiplying by 3, so I'm going to divide both of these by 3. 2 over 3 does not reduce, so the bottom comes up, and I have 3x plus 2 times x minus 18 divided by 3 gives me 6. Alright, start out by multiplying the 4 and the 6, so x squared plus 5x minus 24. So x plus and x minus. I need factors of 24 that have a difference of 5. So 3 and 8. Since I've got a plus 5x, the 8 needs to go with the positive sign. So the 3 goes with the negative. And divide by the a, so divided by 4. 8 over 4 reduces to 2, so I have x plus 2 times 3 over 4 does not reduce, so bottoms up, 4x minus 3. Perfect square trinomials, you can do the same way we've been doing. However, if you recognize them as perfect square trinomials, it can give you a little bit of a shortcut. If I have something of the form a squared plus 2ab plus b squared, it will always factor into a plus b squared. If it's a squared minus 2ab plus b squared, it will be a minus b squared. Alright, so if I take a look at this, 9x squared would be 3x squared, and 49 would be 7 squared. So 3x would be my a, and 7 would be my b. So let's double check and see if the 42x is 2ab. So 2 times a would be 3x, and b would be 7, which does equal 42. So this is a minus 2ab. And if we look back, that means it factors into a minus b squared. And we know that a would be 3x, minus b is going to be 7. So it's going to be 3x minus 7 squared. Here I have 4x squared plus 12x plus 9. 4x squared would be 2x squared, and 9 would be 3 squared. So 12 is 2 times 2x times 3 does give me the plus 12x. So this is an a squared plus 2ab plus b squared, which means it's going to factor into a, which is 2x, plus b, which is 3 squared. $64x squared would be 8x squared, and 1 is 1 squared. 16x is 2ab, so I have a squared minus 2ab plus b squared, which means this is going to factor into 8x minus 1 squared. 25x squared would be 5x squared, and 81 would be 9 squared. 90x is 2 times 5x times 9. So this is an a squared plus 2ab plus b squared. So it's going to factor into a plus b squared. The difference of two perfect squares, a squared minus b squared, will always factor into a plus b times a minus b. So if I have x squared minus 64, x squared is obviously x squared, minus 64 is 8 squared. So I have a squared minus b squared, so a is x and b is 8. So it's going to be a plus b times a minus b. 4x squared minus 49. 4x squared would be 2x squared minus 49 would be 7 squared. So this is going to be a plus b times a minus b.